Part 3, plotting a regression line. This most common used in Math 150, 151, also Math 212. Here you're going to see a list of, we're going to be plotting a regression line that fits data points. So here we have a list for x, this is for f of x. And we're going to be placing these into columns for L1 and L2. How we get there is based at our home screen. If I was to go to Stat and I wanted to edit, here opens the list. You'll see L1, L2. So I'm going to make my L1 be my x and L2 is y. So if I enter the data, I will follow it to be 0. And as I scroll down, 0, 1, 2, 3, 4, 5, and over at L2, it's going to be 3, 7, 10, 24, 50, and 95. The next step, we'll make sure that our stat plot is turned on. Stat plot for this, so we hit second, stat plot, and right now this is currently off. So when I turn it on, I make sure it's on, and it's a list of different ways of the type of way it's going to show the points. The mark is going to give us a little box here, so when we go to our screen to view that, we'll see those data points being listed. So hit enter. The next phase, if we were to go back and say graph this, there's the equation line. Now it's not the best window being viewed for this. If you notice, our highest point goes up to 95 when x is just 5 itself, y is 95. So if I go to zoom, and if it's a zoom stat, it gives a little better line representation of the equation. So in order to feel a line best fits for this, what kind of equation would best fit these data points? If I wanted to stat and calc, and I'm going to just try to see what would happen if we did a linear regression. The regression would just be a straight line. And for instance, it's asking you in this, our x list, once again that was the line at x. The f of x, being a y, is listed as L1 as L2. If we want to change it here, we'd be able to change it by selecting any of the L1, L2, L3, whatever one we wanted to choose. Also, at this point here, if you notice, the first time it didn't have any graph or a line showing tracing those points. This is asking where do you want to store the equation. So we hit vars, y vars. It's going to be a function, and I want it to be placed in y1. And here I'm just going to go calculate. So this is our equation. It's a linear equation. We're trying to base the line, and it gives us our a, which is our slope, our intersect, and then our r value. If you notice, we're getting an r squared is about 0.82. Remember, better we get to 1, better fit it is. But let's do a visual and see what it looks like. So hit graph. There's the data points, and that's showing how it's tracing it. Now the example, if you notice, this is a different window screen than what I have, but they are still the same points, and if you notice, to the same equation. It doesn't really look like it fits the data points that well. If you notice, the data points look like they're kind of curving up, where this is a straight line. So I'm going to go look to see if I have a different equation better fits this data point. So come back to stat. I'm going to calc, and this one I'll move down to exponential regression. Once again, L1, L2, and I want this for regression. I want it to go into vars, and it's going to go to a function and y1. Calculate. And here's the equation that's going to lay into that example. So A is 3.046, B fit here, and then x. If you notice the r square value, that's a 0.99, which is quite accurate. It's closer to 1. Better fit the information is. So if we to graph this, as it follows along, if you notice, is basically intersecting each one of those data points, making it a really good fit. So we can represent that those data points, that equation being an exponential function, really best fits our data set.